Hello and welcome back to the channel, and in today's episode we will be making our first 3D game. I will try to make it as beginner friendly as possible, but as you will see we'll touch on some more advanced subjects like, for example, particle system or persistent data. The game itself is very simple. You run it, you get the main menu. Then you get the select level screen, and to unlock level 2 you have to finish the level 1 first. And if we press it, we get a very simple game with a nice music where you have to avoid the obstacles to get to the end of the racing line. And then you can play the next level, select level 2, and here's a different level, right, where we can jump and avoid obstacles, also to get to the very end. And that's it. So let's get going. Let's start working on it. As I mentioned, I will be trying to make this tutorial as beginner friendly as possible for everybody. So when making a game, we need a game engine. And there are lots of wonderful choices when it comes to choosing your own engine. I decided to use Godot because it's open source, it's community driven, it's simple, and it just clicks with me. So to get access to it, go to godotengine.org and then download latest version. You can also find other versions of the engine if you search for where is it? Let's see. If you search for Godot 4.2 beta, you can also find the newest 4.2 version, but the tutorial that we are making here is done with 4.1. If you download it, you will see that it's very simple. It's basically just a single file that you can run. So let's run it. And if you run it, what you will see, this is the first screen that pops up. This is not the engine itself. It is Godot Project Manager, where you can see the list of your files. You can search for the projects. You can change the sorting. And also, if you download the project from the internet, you can import it. For example, if you decide to download the project from the repository, the link is down below in the description. You can just go to import and browse and find the proper project. That will be the file with the .godot extension. What you can also do is manage tags and add some tags. For example, if I would like to add a 3D tag, right, I can see it here, and then I can add a 3D tag to my project just to easily visually see what kind of projects I have in my list. We'll start by making new project. So let's click new project, and you can click browse to find the proper path, the proper location for a project. I have a Godot folder in my game dev folder. Here I can create new folder. I'm going to call this first 3D game tutorial, and then select current folder. You don't have to worry about other options. The renderer that we'll be choosing most of the time is 4 plus. Version control metadata doesn't matter if you're not using something like Git to basically save your files into repository. And that reminds me that I should probably record an episode about Git for Godot users. So let's just press create and edit. So with the installation done, now it's good time to discuss the UI of the Godot, because it can be a little bit overwhelming as if as with each new piece of software that we are using. Okay, let's start from the top. Here you have your standard toolbar that will be using to manage the project, create new scenes and nodes, and export the projects. Also, you can quit the Godot from here. I will be discussing what scenes are a little bit later. Then you have options for debugging that are available when you're running the projects, and editor settings, and of course help. The help itself is very well built into editor. It's basically offline, and whenever you would like to check some kind of node, you can just double click and this offline documentation will pop up. Then what we have is a set of 4 buttons that basically change the context of our editor and how it works. For 2D games, we have 2D, and here you will see all that you have in your current scene in 2D. Then you have 3D, and these are completely separate. This is the difference between, for example, Unity and Unreal, where 2D in Unreal and Unity is basically built on top of 3D with one axis, the Z axis, basically flattened out. Then you have the context of the script, where we will be writing our code to make our scenes dynamic and basically build our game. You can also use external editors like Visual Studio Code, and I recommend this especially if you decide to build your game with C#. We will be using the GDScript language, which is the language created by the Godot contributors that is very well integrated in the engine itself, and it has some similarities with Python. And then you have the asset libraries, and this is the place where you can find tools or plugins that will help you build your game. We won't be using that right now. In the top right, what you have is a toolbar to basically run your game, stop it, and run it like differently. Here you can run the game with the main scene, because you can designate one of the scenes to be the main, the most important scene. Then here you have the options to run the current open scene, choose the scene to run, and then here you can enable movie maker mode, which is the mode that is used, for example, for cutscenes. Then here you can change the renderer. We choose forward, we'll be staying with that. Next, you have the scene going from the left again. You have the scene tab, where we'll be creating and managing our scenes. The import tab, this is useful whenever you're importing, for example, texture atlas into the project and you would like to set it up properly. Here you have the main window that, as I mentioned, changes its context whenever we press on one of the tab above. Right here you can see the set of the tools that we'll be discussing as we'll start adding scenes and nodes. Then inspector, that is basically displaying all of the properties of the nodes and allows you to configure and change how the node behaves. The node itself, which is very useful when it comes to signals, we will be discussing what signals are, and history, which enables you to track all of the changes and commands in given scene. And then here in the bottom is the file system, which allows you to manage all of the files within your project. I know it's a lot, but then at the bottom we also have another window with set of tabs. Here's the debugger, which we will be using to find errors if any occur. The output, which is like a console that basically display the errors, the warnings, but also the values that you're printing in your code. Then here you have a search results. If you press Ctrl Shift and F, Ctrl F while we have something in our scene, then you can search, for example, throughout your code. The audio manager, the animation, and shader editor, right? We won't be using those two in that tutorial. I know this is a lot when it comes to UI, but I encourage you to discover the possibilities of Godot gradually as you need them. Okay, with that out of the way, I think we can go to the next section where we'll discuss nodes and scenes. Let's start working on our application. First thing we're going to do is discuss what are nodes and what are scenes. Basically, nodes are components creating your game objects in the Godot engine. And there are many. Some are very basic, like 2D node. Some other represent meshes, audio, UI elements, collision objects. These are the sets of objects prepared by the Godot engine team that are the most common when it comes to creating games. And you can imagine that you will have a set of nodes that are somehow working together to create, for example, a gun in your game. Maybe that one is a collision object, that one's gonna be the sound player, and that one's gonna be the mesh representation. And then they can be grouped, and then they can have a hierarchy, meaning there can be a parent node that has its children. So imagine this being like a tree of objects. And then if we decide to group all of them together, this is going to be a scene. So for example, a gun scene can have some simple node 2D as a parent, and then children that are, for example, particle effects, sound effects, and mesh 3D, which is the visual representation. So what we do is we create those scenes and we combine a set of scenes together and those scenes then also can be combined into an even bigger scene. So for example, this is a gun scene, but this can be like your player that has a gun, and for example, inventory. And this player is gonna replace itself to a very bigger scene that will be, for example, your game world, some kind, I don't know, level or a city combined by creating multiple nodes, right? So as you can see, this is self-enclosing tree-like structure when we combine nodes into a scene and then scenes together into bigger scenes. It's very cool because it feels like you're creating a game by using Lego bricks, which is very, very nice. Let's get back to Godot and let's start creating a simple scene. I will start by creating our world scene, which is going to represent the level 1 that we have. So I'm going to choose a other node when it comes to creating new scene, and I'm going to choose node. And this node, empty node, is like a container for other nodes. For example, if you would like to group all of your obstacles, or I know, all of your enemies together, this is like a container node for other nodes. And what I tend to do is call this main. And then we can save it, and it's gonna pop right here. But here in the file system, what I would like to do is to keep it nice and tidy. So I'm gonna click right on the res, which is like the root folder, and choose create new folder. And I'm gonna call this, for example, scenes. Because everything in Godot, every single file with the .tscn extension is a scene. Right now, we don't have much here, but let's start by adding our player. I will click right here and choose Add Child Node, or I can also click here or press Ctrl A, and I will search for a mesh instance 3D. And here you can see that something already popped out in our scene. What we are seeing here is the 3D viewport of our game with some axes. And let's discuss this a little bit. So first things first, we have three-dimensional game because we're making 3D game. So we have three axes. The green is Y and it's pointing upwards and is responsible for moving up and down for a given node. Then we have red one, which is left and right. And then we have blue one, which is Z. The red one is, of course, X. That is moving us front and back. Okay. We cannot see it yet, but if we click on our mesh instance 3D, and we can see now that our inspector here is filled with the properties of that node. Here I can see that the mesh is empty, but I can click on it and choose new box mesh, and I will get a box visible here. And of course, if I will to drag one of the axes, I will start moving our mesh 3D, our box, in a world. And if you go to the properties and click on Node 3D transform, you will see it has a property called position, which is describing the position of a scene or node in a 3D world. And you can see it changing right here. The other thing is that I can change when it comes to basic transform is rotation. And this rotation is represented in a 3D world with those semicircles or circles. So for example, if I would like to rotate my cube around the blue axis, I just have to click and drag on the blue semicircle. And you can see that the rotation is being changed around Z axis. The same goes with the green Y semicircle and then red X. So with that visual representation here possible, let's discuss manipulating the viewport. I can use the mouse scroll to zoom in and out, and you can see that there's information about that popping on the left side on the screen. Then I can click the middle mouse button and start moving to rotate the viewport. Then also what I can do is if I change my camera, I can press F. Sorry, I can press, that would be, if I have two mesh instances, I can press F to focus the camera on what is currently selected in my theme. I can also press Ctrl D to duplicate given object, and then again F to change the focus of the viewport camera. Going back to the tools that we have right here, we can change the use of the context of our viewport by clicking on one of the tools. Here we have move mode, and this is basically just moving. And if you can see, we have those color rectangles here, right? And what are they used for? We can use those to move our mesh, excluding given axis. So take a look at the values here. I'm gonna grab and move the red rectangle, which is corresponding to the x-axis. And if I do that, the x position is not changing. I am only manipulating y and z. The same goes for the blue when the z stays the same, and I am manipulating z axis. And you can access those tools with a set of very simple shortcuts with Q, W, and then E, or clicking here, changes to rotation context. As you can see, I am now again rotating the y-axis. But if I will be to click and hold Control, I'm now incrementing with the values of 15 degrees. The same goes for movement. If I hold the Control, I am now moving it gradually on the grid that you can see right here. Then we have R shortcut or scale mode, right? So I can scale my mesh by dragging here. And of course, what I can do is manipulate the scale or rotation of position by going to the transform position property and changing it by providing a number, right? And you can see in case of scale, what we have here is this chain link here, which scales the mesh uniformly. But if I would like to change it back to, for example, 1, 1, 1, and set it all by hand, I have to unlink this and then just press 1, 1, and 1. And we're back to where we began. Next, what we have, we can lock a node, right? Which will prevent any manipulation of it, right? So this is now locked and I'm not going to change it. Then we have using the local space. And this is interesting because we have two sets of coordinates in the 3D. One being the world coordinates. So the Y is always up, the Z is always to the front, and X is always to the right. But if I rotate that cube, right, the world coordinates stay the same, right? They're still pointing the way they were. But if I take a look closely at my cube, I now can see that its own y-axis is now skewed and pointing at some angle. And if I would like to move in the coordinates that are set for that mesh after rotation, I can click use local space or press T. And now you can see that the axes are set corresponding to the rotation that I have. If I zero out our rotation, then the world coordinates and the local coordinates are the same. But if I were to rotate my cube, Now, of course, they are different. Okay. Then what we have is the use snap, and it is somewhere here. We should have also the snap object to configure snap. So you can see those grid lines here, and if I press Ctrl and start moving, they will snap. Same if I press use snap. But what if I would like my grid to be in a lower increments? I can go to transform, configure snap, and then I can change the translate snap, for example, to 0.5. And now it will snap in smaller increments. What else? Oh, we can also change the viewport here to display given cube in different viewports, and we can configure each and every one of those. I'm gonna go back to one viewport, and then in the top right of the viewport you can see the axis settings, right? For example, I can click on X, Z, and Y to get the orthogonal view, which is like the view without perspective, and it is very useful whenever I would like to align something ideally on the grid, right? And then left, Y, Z. And to get out of this orthogonal view, what I can do is I can just press the middle mouse button and start rotating, and it's gonna switch to perspective. Or here, for example, if I press in the left top corner of the viewport, I have all of the settings regarding the viewport and also the views. So I can just choose a view that I would like from here, and I can change the perspective or orthogonal here. Okay, I believe this is the basics of the viewport and how to manipulate objects in it. And in the next section, we will start writing code and creating our world game. So I'll see you in the next section. For now, there's not much of a game here. So we'll start by adding a floor that our player will be moving on. And I could add a mesh instance and then add other nodes to it and manipulate its properties to create floor. But what we're trying here to achieve is that encapsulation and composition that we get when combining different scenes. So what I can do now is create a new scene and that then add it to our main level scene. So I will go to scene, new scene, choose other node as a root node, and then find rigid body 3D. As you can see, we are now in a different tab. So we're no longer in main, but we're working on a different scene by adding different nodes. So let's discuss our rigid body. This is basically the body that can be moved by using physics, but we can also use it to create a floor that won't be moving at all. And right now you can see that we don't have any visual representation of it, so we cannot see it. But let's add a mesh as a child node of rigid body 3D node to give our floor some visual representation. So I can click here or press Ctrl A and choose mesh instance 3D. And it's still not visible because we didn't give it a mesh. So let's choose from all the meshes that we have here, let's choose box mesh. And now we can see it. So I would like to give it some different properties when it comes to a scale. I would like for it to be like a floor, so long, very long. So I'll change the scale of x to 10 and then scale of z to 200. And now we have something that resembles a floor. Okay. Next thing I'm going to do is rigid body 3D as a name for root node. It's a very generic name. So I'm going to double click and change its name to floor. And with all of that, I can press Ctrl S to save that scene. And now it has a name by default set to the name of the root node. Let's save it. There are still some problems here. You can see that there's an exclamation mark next to the root node, stating that we are missing a collision shape, so nothing can collide with that node. What I can do is go to root node, press Ctrl A again, and search for collision shape 3D. And I can see that it is being added to the node tree, but it won't work because it doesn't have a shape property set. So let's click here on empty and let's find new box shape 3D. And you can see we have something here, but it's definitely too small. What we can do is we can manipulate it to extend to the whole floor. So let's see. First thing I would like to do is make it sync a little, or is it aligned? It looks like it is aligned. So you can see those three white and pink or orange dots here that we can use to manipulate the size of our collision shape. So let's drag those until we can match the size of the floor, and you can see me clicking on those nodes here to manipulate the view just to make sure that everything is matching perfectly. Left orthogonal, I'm going to switch to perspective. Now I can grab this and start extending until I match the length of my floor. Okay, let's see. Now I can see that I overshot a little bit, but this is basically it. This is our floor with the collision shape. No more exclamation marks. What I can do with that scene here, because remember that the combination of the nodes, the tree of the nodes is a scene, is added here as a subscene. So what I can do is I can click here, instantiate child scene, or press Ctrl Shift A and choose floor here. Okay, let's grab it and move it a little bit. And let's see what we get. And I can run my game by going to the top right and pressing run project. And it will tell us that we don't have a current scene for now, the main scene, and we can select current as a main. Okay, and we see nothing. This is because we don't have a camera in our scene. And the camera is actually responsible for rendering stuff to the screen. Also, we don't have another crucial node that we need to display everything, which is a light. So we need to add a light and we need to add a camera. Let's click on the main and I will press Ctrl 8 and search for directional light 3D. And this directional light is like the global illuminating light. You can think of it as a sun basically. So let's try and play right now. Still nothing because we don't have the camera. So as you can see, you might get a bit of a grip of what nodes are. These are like the building blocks handling basic use cases for your game. If you need a light, you add a node. If you need a camera, you add a node. Let's add a camera 3D. And we have it. And now if you look at it, you can see that it has like this wonderful camera-like shape, and it will, what is in front of the camera, it will be rendered into a screen for a given game frame. So to set it up properly, I will rotate our camera by 180 degrees, and then I will also rotate it down by -25 degrees. Let's try now. Okay, we can see something, and we can see that we're moving away from our floor. Why is that? This is because the rigid body by default is being affected by a gravity, and we can disable this in a rigid body by clicking freeze, and now it should not move anymore. There's also another possibility. We could change the type by clicking right mouse button on the floor and change the type and search for a static body 3D. Okay, that's also a possibility. And basically, now that I think of it, we could use a static body for something like a floor or any other wall or obstacle, but let's stay with that. Okay, so what I can see is the floor, but I cannot see the player itself. So maybe let's click on our mesh instance, bring it a little bit further. See, yeah, we can see it, but right now it doesn't really look so good. So let's change a few things here to make everything a little bit more visible. Okay, so what I'm going to do is go to project settings, and here I can find all of the settings in my project. One of the settings that I would like to change is basically the background color. So let's see, the default color, you can search here for a clear color. This is, let's change this to 155 155 155. So this is RGB. Okay, and that should change the color of our background to be a little lighter. Then I would also like to change the color of my floor. And to do that, I have to go into mesh instance and find the material, and we can find it by filtering the properties here, and then let's see, we are searching for surface material override, and I would like to make it basically all white. So what I can do is create new standard material 3D, click on it, and to set the color itself, we can find the albedo, and you can see it's all white now, which is all right. We can go back to main and run it right now, and we can see that it is still not visible very clearly. The reason why we cannot really see our light hitting the surface of our floor is because the rotation of the light. If we zoom a little bit closer and focus on the light, you can see that arrow here, which is pointing towards the vector of the light emission. So we can change that by going into our light. So we can select it and go into the transform in inspector window, and let's change the rotation of our light to -50 per x. And you can already see that the floor color changed. Then I have 50 for y, and for z -75. And now if we take a look at it by running our game, now we can see everything lights up properly. So we have our floor, we have our light, and in the next section we can look into our player and start coding with GDScript. Let's focus on making our player work. So our player is going to be very simple. It's going to be this cube you can see on the screen, but right now we cannot affect it in any way. And as you can see, it's not being affected by a gravity. So to change this, let's delete this cube and let's create new player scene that's going to encapsulate everything regarding the player. So let's go to scene, new scene, and we will use rigid body 3D as a root node for our scene. And we need to add the visual representation. So let's search for mesh instance 3D. And then let's add the new box mesh, and we have it. Let's change the name of the root to player, and then we can save it as a scene in player scenes, in the scenes folder, sorry. First thing I would like to do is to change the color of our player cube. So let's go to surface material override property in the inspector after we click on the mesh instance 3D and choose new standard material 3D. There's a lot to it really, but what we will change is only the albedo, and I will make it all red. So let's set the green color and blue color to 0 and 0. That should give us nice red color. We can collapse this. Then of course we need to add the collision shape. So let's click on the root node and add a chart, and let's search for collision shape 3D node. Then in inspector, let's click new box shape, and you can see since we didn't change the scale or shape of our cube, the default box shape matches it perfectly. Okay, and then let's bring that to our level, and I can see that the floor front axis is pointing that direction. So I would like to add my player somewhere around here. So let's go to instantiate chart scene, player. Let's move it to the front of the level. And I can see that it is sinking into the floor, so I need to move it up a little bit. Okay. And also it's not going to be visible in camera. So let's move camera here and let's try running our level, and I can see it pretty nice. Okay. Let's maybe position the camera a little bit closer. Let's find a good angle. Okay, this is pretty nice. Let's see if our player is affected by a gravity by now. So let's bring it up and let's play, and I can see it falling down and sticking to the floor. Perfect. But if we play our game right now, you can see that I cannot move it and manipulate it in any way. To do that, we will need two things. One is the code, the GDScript code that will move and control our player. And second is the definition of how the input from our keyboard or mouse should translate into actions performed by my player. Let's start with the last point. To define the controls, we can go to Project Settings, Input Map. And here I can define actions that my player can perform and the corresponding keys. So let's define forward, slow down, left, right, and jump actions. These are the actions that my user can perform in a game. To assign a corresponding keystroke to it, I can go to the given action and click on a plus on the right side, add event, and then press the key I would like to listen for to perform given action. So for forward, I'm going to use W, slow down is S, left is A, right is D, and jump is space. As you can see, there's a lot of options to it. We can remove the event, the keystroke, remove the whole action, add another keystroke. For example, we could add up key. And another is down key. And so on. But I'm a pro gamer. I'm gonna use WSAD. Okay. We can also add a dead zone. This is more interesting when you're using a gamepad to move your player to introduce the dead zone of the thumbstick. Okay, with this set, I can close. And now we have to start coding. So if I would like to move from my main scene into the player scene, I can click on the tab, or here, this is the scene icon. I can click it and I will be taken to the corresponding scene. So we will be coding with a GDScript, and what is nice is that we don't have to leave the Godot engine to write the code, because there's an input code editor which is pretty good actually, that allows us to write the code. So to add the code, we can click on that icon with the plus in the script, and it just says attach new or existing script to the selected node. So in our root node, let's add a script, and here you have the language. Currently we have only GDScript configured. There are other possibilities. You can write C#, C++, Rust, and others. What node it should inherit from, and basically this means that our code will get access to some properties and methods out of the box from the code that is used to run and define this type of node. Basically, there's no reason to change it right now. The template, we leave it like this. The class name is not available, that's okay, we'll add one. What is interesting for us is the path, again, to keep everything nice and tidy. I will click on the folder icon and go here to go to parent folder and create new folder here, call this scripts, and go into that. And here I will press open and then create. And what will happen is a few things. One thing is you can see that here we have the icon, informing us that given node has a script attached. So there's some code. And then our editor automatically changes context from 3D to script. And here we can see our script editor, which is very simple yet sufficient for our needs. Here we can filter scripts, we can close tabs, we can basically do everything that there is to edit the code. Here we have online docs and also search help. We can also make the script editor floating. This is whenever you'd like to move it to a separate monitor. This is a very cool feature. But I will have it embedded here so that you can guys see it. Now this all might be very confusing for you, so let's go step by step. The words that are in pink red color are the keywords in the language. These are the words that are used by GDScript to define some special functionalities. For example, let's get rid of that. The word extends means that we are basically inheriting and getting every single property that there is from rigid body 3D. And this is because the same as nodes, our code also is like a tree structure, right? So for example, the tree structure that we have in our code, let's change the color. It's like we have a basic node code for the node of type node. And then if we get node to D, it has everything that node has in it, plus, for example, a position, because it can be placed on a screen. And then, node 3D in our case. And then, for example, in our rigid body, what we have is gravity scale, because our node can be affected by the gravity force, right? And then we will be creating our own node, which is a where is it? Which is a player, right? Which can be controlled because we'll add some code. And then you can imagine that this might be extended further to add more classes, right? So basically we have a node in an engine, and then we have a class in the code. And you can imagine that this class, right, is like a blueprint. This is just like the wrapper for some variables and functions, which we'll discuss a little bit. Okay, so we are getting everything that there is in rigid body, and if you would like to know what is in rigid body, you can control click, and here you have the whole documentation about rigid body 3D. So for example, if one of the properties is the mass, I will have the access to I would have in a function, but we'll get to that. Right, so everything that there is in a rigid body, every single method and property, we now have access to it in our code. So the first thing that we have to discuss when it comes to scripting in GDScript is that we have basically two types of things. Let me just clear this out. One thing that we have are variables defined with the keyword var, right? And variable is just a box for you to store something. So for example, I could store the speed of my player by saying var speed is equal to 200, right? And what that does, it creates the place in the memory of your program and of your computer to store that integer value. And of course, this is a keyword. That means you cannot create a variable with the name var or extends. So to define this, I can just write var speed 200. And let's see what happens if I try to name var. You can see there's an error. You can see all of the errors in your code right here at the bottom. It says expected variable name after var. So this is a syntax error, meaning we have written something that cannot be really well understood by the GDScript. Is it interpreter, because that code is interpreted, right? So this is incorrect, right? It's like saying incorrect sentence in English or any other language, right? So, but when I do this, now it's correct. And let's discuss naming a little bit, because basically we have two types of naming syntax in GDScript. For the classes, and as you can see also for the nodes, we have what is called, I believe, Pascal case, meaning that the first letter is big, then you write the word, and another word is also big. This is for classes and for nodes. And then for variables and functions, we do underscore case. So if I would like to define horizontal speed, I would say horizontal, and then add an underscore here, and then write a second word. This is the convention that is in GDScript. It is different in different languages, but that's what I will be sticking to when naming stuff. Okay, cool. The other thing that we have to discuss are functions. And they are defined with the keyword func, like function, right? And in nodes, you have two types of functions. One type of functions are functions that you inherit from the parent node. So in our case, we inherit from the rigid body. Right? And we will get some functions like for free because we extend the rigid body. And the other functions is the functions that we define and write and use ourselves. And you have to know the difference between those two. Variables are things like speed is a verb. I believe I'm saying this correctly. And then the functions, they do things. So this is a noun, if I remember my English lessons correctly, probably, but don't judge me if I'm wrong here. But basically they do things. So for example, we could say calculate new speed. And as you can see, calculate is like something that you do, right? And then we have to discuss a very important two functions that we get for free from rigid body, or basically from every other node. And this is ready function and process function and physics process. These are what is called callbacks. I mean, they are not being created and run by ourselves, but rather are created and run by engine. This function is like called on start whenever the node becomes active, or after the creation of the node, but basically when it becomes active. And then process is called continuously in a span between some spans of time. So this is basically our game loop function. And also this. The difference is internally between the process and physics process. So whenever we are doing some calculations with the physics engine, so changing stuff related to physics like velocity, for example, or changing mass, we should use physics process so that it can be calculated. Everything else that is being called continuously, we can call in a process. Okay, so how does it work actually? Let's go back to our engine and let's write func ready. So this is the function that is a callback on the start. You can see that the definition of the function is ended with the colon. Of course, since func is a keyword, right, the same as var and extend, I can write something like this, right? It makes no sense, and you can see that line highlighted in red and also information about it here. But what I can do is I can print something to the console right here, and this is very useful when debugging, by calling another function print, and you can click on it and you can see that it is being used to display something to the console, but it takes what is called argument. So we have to provide here in the parentheses what exactly we would like to print to the console. And I'm gonna just say player start. And now if I clear the console by clicking on that clear output button here, and if I run my game, and if the player is in the main scene, because we're running the main scene, I should see an output here. And here it is, player start. So this is getting called for the player node whenever it becomes active. And then let's check the func process, which actually comes with the parameter out of the box. So this is a variable just like that, but we get this provided by the engine itself. And this is delta time, which is very important argument we get in process and physics process, because this process and physics process functions, they are being called multiple times, like hundred thousands of times whenever our games run continuously, right? But the how many times and how the function gets called is not deterministic. That depends on the stuff like how fast is your computer, how much code do you have, how complex is your function. So it is getting called, and we have some intervals between the calls. And the time between those calls is called delta time. And it is being used to basically make your game run time independently. Imagine the situation where I have very fast computer, and for example, this whole takes 5 seconds, and I'm getting that process function called like 20 times. And then my friend has a very slow computer, and his process is only called 5 times in 3 times in those 5 seconds. And each time I'm getting that process callback running in my game, I'm moving my player like 1 meter, right? This means that in case of my computer, my player have moved 20 meters. But the same game running on my computer, on the computer of my friend, is being moved like 3 times. So this is 3 meters. Obviously, it makes no sense for a character in game to move 20 meters on one computer, but then 3 meters on the other computer. So what we do is we incorporate that delta time to multiply all the movements time delta time, because this value is way lower on my computer than it is on my friend's computer. Here it is way bigger. In the end, we'll both move the same amount of meters, right? Because if here I duplicate, I multiply times, I know, 10 and 10, and here I always multiply by 1, in the end we get the same result, okay? So this parameter or argument is to make the game run smoothly and in the time independently, or maybe even machine or resource independently across all the computers. Okay, so let's print this and see what it is and how it works. Let's run it again, and you can see here I'm getting the delta time, and I would get the same in physics process. So I can print 2 lines here, physics process, and then delta. And if I run it, you will see, going to the very top, that first the physics, the process is being called, then the physics process, then again process 2 times, then physics process. So you can see there are differences between which one is getting called, but it shouldn't impact our game right now. Okay, is there anything else before we start working? Well, there is one thing. There's another very interesting callback that we might, but we don't really have to use to read the keyboard. And this is input callback, input callback with event parameter. Okay, and this is a place where you might read the input of your user to make your game run. You can also do this in process. I tend to keep it separate in the input event. So I can just write func input, and here you can see the autocomplete is helping us very nicely. Okay, and I can just print event. And as you can see, I'm not moving my mouse, I'm not pressing any keys, and you can see that the output in the console is not moving. But as I try to press stuff, now it changes. And now if I move my mouse, it will also print. We have a lot of information here, like relative velocity, the position of in that situation, that's going to be a cursor. So if I go here, it gets closer to 0, 0, right? It's 4, 0, and here it's gonna grow. Okay. Do we need anything else? I don't think so. So what we can do is we can start coding. I will try to go slowly. I will try to go step by step. But if something isn't clear, let me know in the comments, and I will try to help. So, first thing I would like to get in the information about the current input that the user provided. And here I have a chance to define the type of it, because GDScript has some static typing to support. I tend to use it from time to time when it's needed, but I would like to discuss the very important type, which is vector. And you have for vector 2, vector 3, vector 4. And what vector is just a code construct that holds values. In the case of vector 2, that's going to be x and y values, and you can probably see already why those values might be important. Basically, everything that happens on screen has its position and location or scale. And then, of course, you have vector 3, which we will be using for our 3D game, and this is x, y, and z. So values corresponding to all of our axes that we see in our 3D world. So I can say that this will be of type vector 3 because I would like to store those 3 x, y, z values here. But I will initiate it with the value of vector 0. So your variables can have the value assigned by using the equal sign. And vector 0 is this very specific vector that for all of the values here, and z, it has just 0, 0, 0, which corresponds to the center, the middle of your 3D world. And then I would like to assign a value to the input, and I will do it in the input callback function. So let's write this again, func input event, and I will try to get a value here. And I can read it and assign a value here by checking what is pressed by user. So I can say if input, and this is the class, the code that is responsible for reading the input. And then by pressing dot, I can access all of the properties and method in that module or that class. And I'm going to search for is action pressed. And here autocomplete shows me the actions that I defined in the input map. And I'm going to search for forward. So this if lets me check whether something is happening in the code, right? If a person is moving, then do something, right? Or if input is pressed, or if something going on in my code. And this is like the conditional. So the construct is if, then we're checking something, and then we have semicolon or the colon, sorry. And I'm trying to simplify it, but also move us along because we have 33 minutes on the clock in that section. And then I can say, if we're moving forward, then probably I should set the z property of my input, because this is vector with xyz property, to 1. And then let's print this. Let's print the input after that. Okay, so let's clear this, let's run it. And I'm going to press, here you can see it's 0, 0, 0, continuously being printed in input because we started our game with the input set to 0, 0, 0. And then if I press W, you can see that the Z property is changing to 1. Perfect. And I believe this is the right time to stop this section and handle the input in the next section. Going back to handle everything regarding our input. We could also write else if. So if we're not pressing forward, let's check if we're pressing the backward or slow down. We call this slow down. And I could say input z is equal to -1. Sorry, action pressed. And that would work just fine. The problem is there are better ways to handle this. And if you check the input class, you can see that there are many really cool methods to handle the input, right? So what we could do to calculate our input is we could check the positive value of given axis. So for example, forward, and then subtract the negative value, so like this, of slow down, to get the all over input for the z axis, right? Because the difference between the positive and negative is gonna give us the value that we should apply to z axis. So there are always smarter ways to write our code. And what we could do is we could say input will be equal to vector3, and that's the very same time as here. And then we could provide the values for all of the axes, so x, y, and z. And we could get that by saying input get action row strength of, this is for x, so that's gonna be left minus right, I believe. So that's gonna be the value for x. For 0, since we're not moving up and down, at least not with the WASD keys, we can provide 0 here. And then say for z, let's get action row strength or forward minus input get action row strength of slow down. So here we have the value for X, Y, and Z. Okay, but how can we translate that value into movement? We can do that by utilizing the physics process callback. And here we can calculate the velocity. And what we have, thanks to extending the rigid body 3D, is linear velocity that is controlling the movement of our player. So here, the body linear velocity in units per seconds. Okay, so if I will just say that this is vector free forward, which is like positive z value, and I run my game, you will see that the cube is moving towards me. Okay, let's check this. Right. I believe it should be moving. Is this forward? Because it should be moving. Let's see. I believe it should be moving to that direction. Let's see. Player code forward. Okay, forward is -1. I have no idea why. But if we change it to back, then it's gonna just move towards the end of the floor. Okay, so what I can do is use the input to apply the proper linear velocity values. But the problem is, what I would like to achieve is not that immediate jump from 0 to 1, but I would like to have this just a little bit of gaining speed and slowing down. So I don't want to set it immediately to 1, but gradually increase the speed, right? 0.4 and so on, so on, so on, until we hit 1. Okay, so to do that, I could use linear interpolation, meaning that each and single frame, I will be increasing my speed a little bit until I hit desired value. And we're gonna use lerp function for it. And in our case, the specific version, which is lerp-f, meaning linear interpolation for float values. So let's do this. Let's see. Let's get rid of that line. And then I will say, I have read the input value. So here I have access to it. And I can say if input z is not equal to 0, so checking whether we're pressing something in the input, whether this is W or S, I can say linear velocity z is equal to lerp f, and here I can see the arguments I have to pass to that function, and this is from, to, and wait. So the starting value for this frame, and then towards which value I would like to move, and how fast I would like to move. So let's say from linear velocity to, let's say, speed, which we defined here, And how fast we're moving? Well, I can define something here like another variable called vertical speed increment. And I believe I set this to 2. And let's say vertical speed increment. But is vector free? Oh, this is, of course, should be linear velocity z. And now if I run it, you can see if I press W, our cube shoots front. Okay, that means that, of course, the vertical speed increment is too much. So I can say times delta, because we need to incorporate that delta in our movement. And now it is slowed down. I can lower this probably even more, say 0.2. And let's see. Yeah, now it's moving and you can see it rolling, which is pretty cool. Okay, so we have that movement set up, which is really, really good. What about moving forward? I mean backwards. If I press S, it is still moving forward. Doesn't matter if I press S or if I press W. So to incorporate the sign, so where we're moving front or back, I could say times sign input dot z, and sorry, not sing by sign, and the sign function here is going to take some value and return the -1 or 0 or 1 depending on the value. So for -6 it's gonna return -1, for 6 it's gonna return 1. Let's try this now. So forward with W and then backwards with S. Cool. We can now move our cube. Let's do the very same for the horizontal movement. So I'm gonna say var horizontal speed increment, and let's set this to 0.1. And now it's going to be very similar. So first, let's check if we have some input for the horizontal movement. So let's check input X, whether it's not equal to 0. And a word of advice, one remark, this single equal is assigning the value to a variable, and if you would like to check whether the variable is equal to something, use double equal operator, or to negate, exclamation mark and then equal operator. So let's check the linear velocity x, and we're going to do pretty much the same. So lerp, and then we do linear velocity x as a starting value. Then we do speed, and the third weight parameter is sine input x times horizontal speed increment times delta. And let's see, yeah, we can move to left and right, front and back. So now we can control our cube. So in this section, we'll adjust the properties of our player's rigid body. we'll give him ability to jump, and we will also discuss signals. So let's see what we'd like to discuss. There's a lot of properties when it comes to rigid body. The one that I would like to adjust is contact monitor, because then we will have, if we press on, we will have the ability to emit signals and be informed about how we're moving and when we're hitting something. The other problem that I would like to discuss is, what I don't like is that when we're running, we can basically rotate around the axis. And the only axis I would like to rotate around is the y-axis, right? So if we take a look at the 3D, this is the only axis I would like to rotate around, like this. I don't like that my player is rotating around z-axis or x-axis. So what I can do is go to physics body 3D section and choose axis lock, and then I can disable the rotation around angular x-axis and angular z-axis. And now if I press play, we don't have it anymore. So this is the first thing that I would like to do. Okay, the other thing I would like to change is to give my player the possibility to jump. And let's see how can we do this, right? Here in input, what I could do is just say input is action, and here we have a choice. We have is action pressed and is action just pressed. And there's a difference. The action pressed is gonna be called whenever we press and hold the key. If we'd like to monitor the singular key press, so just like single keystroke, we need is action just pressed. And for jumping, I'm interested in a single press, so let's choose is action just pressed. And then let's choose jump. Then I could say we need to find a way to make our player move in y-axis, so move up. And there are many ways to do this. We could change linear velocity y value, and that would be good. But the other way we could do is jumping is just like applying a force or an impulse to a rigid body, and there's a function for this specific case that we could use that we get access to because we extend rigid body 3D, and this is called apply central impulse. And here we have to provide vector free. So we can construct this by saying vector free and seeing what axis we're interested here. So for x-axis, we don't want to move. We would like to move some value in y-axis to imitate the jump. So this is 100, and then again 0 for z. Okay. And let's press play and let's see. Okay, that's a little bit too much if you ask me. So let's change it maybe to 10. Okay, we can jump now. It's still a little bit too high, so maybe let's change it to, let's actually define a variable here. And we have variables to which we can assign the values, but there's the other type that is called constants, which means the value that is defined but will never change. And typically the naming is a little bit different because it's all uppercase. So I can define a jump force constant here and call this jump force and set it to 5, right? And this is just to avoid those magical numbers that make our code hard to read. So let's copy that name and apply it here. And now here, when interpreting that code, this will be replaced by 5 value. Try this. Okay, this is pretty good, but the one problem is that if I press space while mid jump, I can basically jump I can jump many times. Okay, so we need a way for us to avoid this and know whether we're in the air or not. And we definitely are not jumping after the jump when we touch the floor again. But how to know if we landed on the floor or not? Okay, we would like to get that information somehow, and there are few components to that. First, when things are colliding in Godot, we would like to assign them to a specific layer to know what elements can collide with what. For example, if you have some kind of checkpoint, you don't want to treat it as an obstacle, so the player does not collide with the checkpoint but just rushes through it. But if he hits a rock, that's an obstacle. So we need different layers to assign different things to different layers. So we can go to project settings, general, clear that filter here, and let's find layer names, 3D physics. And let's define few layers that we'll use in our game. So this is player, obstacle, floor, and something I call player detection area. Okay, and now in our player we'll find collision object 3D section, collision, and here we have two sections, the layer itself and the mask, and you should read those basically as that node is existing on layer and can collide basically with other objects defined in the layers specified in the mask, right? So definitely our player is existing on a player layer, and the player shouldn't collide with itself, so let's uncheck that, but it should collide with obstacle, the floor, and the player detection area. So let's click on those. So now that I know that the player exists on a player layer and collides with those layers, let's go back to our main or to our floor, and then click on the root node here and find again collision object 3D, and let's see here the floor is not a player, it's not an obstacle, it's a floor, and it should collide with player and obstacle, not with itself, and not really with player detection area that we'll add later. Okay, so we define the collision right now. Okay, so now I would like to know when we collide with a floor, and I would like to have a way to say that I definitely collided with a floor and not an obstacle, which we'll add later. So what we can do is we could go to a floor scene, click on the root node floor here, and add a very simple script. Let's click on attach node script. Let's place it in the proper folder, which is the scripts folder, and then click open. The name floor.gg is good. And now we are inside of our script context and we're looking at the floor script. It also extends rigid body 3D, and we can get rid of everything else because we will need only one thing here. To determine with what we're colliding right now, we could add a class name, which is another keyword that is defining that a given node is of given class. This helps when it comes to collision detection, but also when it comes to autocomplete feature of our editor. And I will name this floor. Okay, perfect. Going back to our player, what we will have to discuss is signals. So let's get some space here. So we have our scenes and our nodes, and sometimes, basically pretty much very often, what you'd like to get is a possibility of communicating between two different nodes, right? So for example, I would like my player to know that it hit the floor. So for my player, I would like to get the information about hitting something, right? And how should the player behave in it? So what we have are signals. So some nodes can emit what is called signals, which is like the information that something happened within your game or with the node, right? And this signal can be listened to, and then we can react to it. So in our case, we have the floor and we have the player, and I would like to know when the player hit the floor and be informed about that event so that I can do something. In our case, we'll re-enable the jumping possibility for our player, right? So this basically, the signal is like glorified observer pattern, meaning that one node or one piece of code is monitoring some event, and then it just broadcasts and informs other nodes that something happened, and you can listen to it and react in other place of your code. And this is like the most basic mean of communication when it comes to communicating between nodes, but it covers a lot of cases when it comes to creating your game. So I want to know basically when my player's rigid body entered another body, which is a floor, right? When that happened. So how to actually listen to a signal? Well, if I press on the player rigid body, I can switch here to Node tab. And here you can see that we're in the signals context. There's also groups, but we won't be using that right now. And in signals, I have some signals emitted by the object, the node, node 3D, collision object, and a rigid body. And they're going from bottom to top in the order of the inheritance of my node. And here in my rigid body, I can find something interesting, which is body entered. So when the body enters another body, this signal is emitted. So I would like to use that signal in my code. And to do this, I can go to the rigid body, body entered, double click on it, and then we have a window that says connect a signal to a method. And from signal, we can connect to a script. The only script that currently exists in that scene is in the root node, and the receiver method, so which method will be called, and on body entered, the default name is fine. If I would have some predefined method here, I could pick and choose it here by clicking on that pick button. And if I will click connect, it's gonna generate that method inside of my root node script, and then I can use that information. So it is automatically generated. You can see here that it has this icon here, right? Saying that, oh, this connects and it is a signal. Okay, so let's print the body here. And let's see what happened. And there's nothing here, right? It feels like we're not getting any connection. And this is because by default, rigid body is not set to emit the signal. I am in the floor scene, and here the contact monitor, as you can see, is disabled. Okay, if true, the rigid body 3D will emit signals. Okay, let's turn this on and let's try again. Still nothing. And this is because the max contacts reported it's set to 0, so it still won't emit the signal. But if I will turn this to 1, still nothing. But if I will go to player and turn this to 1 and press play, now I get the information about the floor. One thing, let's check whether we can disable that and set it to 0. Still good. Can we disable that? Yes. Okay, cool. So it's enough to turn it only in a player. And then I can see that this is a floor. But how can I be sure in my code that this actually is a floor and not an obstacle or a player detection area? I can say if body, and there's a keyword is, and I can, because I defined the class name for the floor called floor, I can check whether this is a floor. So I can say then print we hit the floor. Okay, and let's play this again, and we have the information that we hit the floor. Perfect. So let's make our jumping work actually. We'll do that by defining another variable that we will treat as a flag, as a switch that we can switch on and on. So we'll define can jump variable, and for start we'll set it to true. And this is a special value, Boolean value, that says whether something is true or false. It's like 0 and 1, on and off. And at the start we can jump. So here we can add another condition. If somebody press input, is action just press jump when somebody hits space, and then we can add another condition that has to be fulfilled by writing and keyword can jump, then apply central impulse. And if we're in the middle of the jump, we will say if you're in the middle of the jump, you cannot jump anymore. So now if I run it, I can only press once space, and then if I press space again, nothing happens. But I can turn this jump feature back on when we hit the floor. So can jump is equal to true. So in the middle of the jump, you cannot jump again. But then if you hit the floor, you can jump again because we change that switch back to true. Jump and jump and jump and jump. And we can still move and jump. Perfect. Cool. So this is how we can add a jump feature to our game. If we run our game and start moving, you'll see that there's one problem. The camera is not following the player, and it just looks strange when we're moving away from the camera. So I would like to find a way for us to synchronize the camera position with the position of our player. And to do that, we can do is in our code synchronize those positions. We have access to the position right here. This is the property that we get. The problem is we don't really know how to pass information about camera node here. And thankfully, GDScript, you have access not only to simple variables like numbers or vectors, but also you can reference nodes. And I could define a variable here. Let's call this sync position node. And I could even give it a proper type by saying colon, and that's going to be node 3D, which is like the parent node of every single node that has a position in 3D world. But how to pass the information about camera, which is in the main scene tree, into the player to synchronize it? Well, thankfully, the code itself has some integration with the editor. And what I can do is say, use a special command here and say at export. And this special keyword is going to enable the property in the inspector that can be passed here. And what I mean by that is now if we go to player inspector, you can see that there's a new section called player GD, sync position node, and it says assign being empty. So the same going to be available if I go to main and click on player. You can see this is also available here. And if I click assign, I can pass a reference to a different node from the current active tree. And I can choose camera 3D. I can clear it by clicking on that icon here. And then the other way to assign it is to click and drag and drop it here when the assign button is highlighted. So now in my code, I'm gonna have access to that camera, and I know that the value of that is actually my camera. And this is other way that you can use to pass the information between your nodes. So not only the signals, but also the direct references. And then to synchronize the position, what I can do is say func process, and we will not be synchronizing the position or the location of the node by using some physics, but we'll do it directly by changing the position. So we can use process instead of physics process. So sync position node, its position property should be equal to vector3, and let's see, I would like to move it left and right and front and back, but the height of the camera should be the same. So for the X, I'm going to say position X. For the Y, I'm going to pass the position of the camera, which is sync position node, position Y, and then position Z. And let's try and run it. And you can see something strange. We cannot see our cube anymore. And this is because I need to add some offset. So what I can do is create a variable here called camera Z offset and set it, for example, to 5 and subtract it here. Let's see how it looks right now. Way better. But to give ourselves more control over it, I can export it, and then it's visible here. And take a look at this. If I run the game, I can change it, and it's going to be dynamically recalculated, right? So that I have control over the offset, and without even stopping the game, I can adjust it to my needs. And 5 is good enough. So the export keyword is very important because it allows us to manipulate those variables and those properties via editor, which is really, really great. So now we have the camera set up. Perfect. So I think we have everything regarding the control of our player. And the next step is going to be adding the obstacles to our racing course. So the next feature I would like to add to our game are obstacles that will fall down into the floor and somehow hinder the movement of our player, or at least make it more difficult. So let's get to work and let's see how can we get that going. I will start by creating a new scene, and I will choose other node to choose the rigid body 3D again as a root node here. I will add a visual representation by adding mesh instance 3D. I will choose the new box mesh and we will transform it a little bit. So let's see, we have a mesh instance. Let's change the scale, so that's going to be 2, 1, 1, and 1. And I will change the root node's name to obstacle. We're kind of moving a little bit faster right now, but I hope you can keep up. In the collision, we'll change the collision layer to 2, which corresponds to obstacle layer name, and it should collide with the player and it should collide with a floor. So let's save it in the scenes folder. And I will also override the material and change the albedo, so the base color, to fully black. And we can also change it to be more metallic. So with metallic set to 1, I can see that this is like deep dark. To make it work, I have to, of course, add the collision shape. So let's press Ctrl A and find collision shape 3D. And this needs to have a shape. So new box shape 3D. And then again, I can see that we have those white and pink circles that I can drag to make the collision shape match the mesh instance 3D. And we basically have everything right now. So let's go back to main and let's find a place to add our obstacle. So I can press on main, then instantiate child scene to bring another scene into that main scene. That's going to be obstacle. Let's bring it back and let's see what happens. And I can see that I have an obstacle now. And if I hit it, I'm going to be blocked. And woo! Even moved a little bit because of the collision. Great. What I would like to change are few properties that we have on a rigid body right here. So first things first, I would like our obstacle to be very heavy. So let's change the mass to 2000 kilograms. Then what I will also need is to create damping for angular and velocity. So I will change this to replace and change the linear damp to 20 and 30, and this just basically changes how our rigid body will react to getting hit. Let's go back to main, let's bring this closer. Okay, and the problem that you can see right now is that it falls down really slowly. Okay, but still works as an obstacle. Cool. What else do we need here? Uh, Basically, we will need some code here, because what I would like to get is I would like my obstacle to hang in the sky until the player is close enough for it to fall down. So it's not falling down like immediately. Right. Let me see. Can we maybe change it to 200? Okay, it's still falling down really slowly. And let's see. Let's see where we have collision set up properly. We have. Okay, and then for the damping, maybe we can disable that. Yeah, now it feels way better. So let's set the damp to combine and to 0. Okay, so I would like to know how far we are from the player before our obstacle starts falling down. To do that, I will need a script for my obstacle. So let's add this. Let's change the location to scripts folder, and let's create that. So first thing I'm going to do to disable the falling down at the very start is I'm going to get access to property called gravity scale, and I will set this to 0, and that will stop the gravity from affecting our obstacle. It just hangs in there. Perfect. Then I have to get the access to player here somehow. And we saw that we can get the reference by using the signal when we'd like to be informed about something. We can pass the direct reference, but since we will be having many obstacles, that's not going to be the most efficient way to do that. What we can do is use groups to get the access to a player that we would like to find an obstacle. So going here to a player and then switching to node, now I can switch to groups context. And now I can manage groups and create a group for my player. And groups are basically like tags that allow you to find something in your game tree. So manage groups. And then I'm going to create here in the input below at the bottom a group called player group. Now click add, and then let's see, let's go to main. Oh, let's first switch to main to add the group. So manage groups, player, and here I will filter nodes and find the player group. So main player in that tree, and I will click add and OK. And now my player, as you can see, we have information right here that node is in this group player. Perfect. Going back to my obstacle, I can say we need a variable to store the player, and then I can assign it by going to get tree, and then on the tree itself, it returns scene tree, which is another class. I can call another method get first node in group player. Cool. And that's how to store that reference. And I'm doing that already on the very start, but I will be using this in process just to keep that reference once and basically cache it so that I can use it later. And if you need some references, it's generally a good idea to do it once in a ready function. Okay, then every single frame I have to calculate the distance between the player and obstacle. So I can do this in process and say player z vector is vector free 0, 0, because I'm only interested in the distance in the z axis. Player position z, and then this obstacle z vector is of course obstacle z vector is vector 3 0 0 position z, and then I would like to find the distance between those vectors. This is vector 3, or rather player z vector, and there's a method called distance to obstacle z vector. And then what I can do is decide what distance should be between my player and obstacle for the obstacle to start falling down. So I can say fall down distance is equal to 10, and I can export it so that it can be manipulated inside the editor. Perfect. So now I can say if distance between the player and obstacle is less than fall down distance, I can just re-enable the gravity and set it to 1. Okay, let's see what will happen now. I can see it staying in the air, and then as I'm moving closer, did it fall down? Yeah, it did, but I'm just moving too fast, so let's actually bump it up to like 40. Okay, now you can see it's staying in the air, and as I'm drawing near, maybe you can switch it to 30. Yeah, this feels good. Okay, I can see the problem right now is that it's really hard to jump over the obstacle, so we can adjust the jump force and set it to something like 8. Let's see where that makes it easier. Yeah, okay, cool. Even a little bit overpowered, but this is fine. So now we have our obstacle working. So what we can do for our level is to go to main and create new empty node to group all of our obstacles. I will call this obstacles, and drag and drop it here. And then basically we can just duplicate those and start placing those in our obstacle course, and you can even stack those on top of each other. You can change the height. And if I go to that view, I can see that some of them are outside. So let's move them back in. This is because that our camera was in perspective mode. So let's readjust that. And let's see. Okay, and we're moving way too fast for our game to make sense. So let's go to our player script and let's decrease the speed to maybe 50. Try this now. And this is way too slow. This is better now. Yeah, now we will have some problems. Okay, also jumping can be a little bit more adjusted to 6. Okay, still a little bit too fast. You can play with these values or with how fast we're achieving the top speed. Let's move out. Okay. Now we can avoid everything and stop. So in the next section, what I would like to do is enhance our obstacle a little bit by adding some sounds and particle effects to it. Let's enhance our obstacle. And I would like to do two things here. Add the particle system to basically render some particles whenever the obstacle hits the ground, and also play a sound. To do this, first we can go to our obstacle scene, press Ctrl A and search for particle system about, GPU particles 3D. Okay, and here we have a problem. Nothing is visible because meshes have not been assigned to draw passes. This is fine. We'll configure our particle system right now. And there's a lot that you can achieve with a particle system, like fire or snowstorm, but we'll try to keep it very, very simple. So let's start with the amount. I'm going to set this to 20, and then we can configure the time. Lifetime, that should be 0.5. Then one shot, yes, so only render the particle once. And what we can see right here is the GPU particles 3D box. So basically in what 3D space those particles should be rendered. And I'm going to make it basically very small, even smaller than that. Sorry, and let's disable the snap so that we have more control over it. Also very thin. Basically the width around the width of our box. Let's place it in front of the box and near the bottom edge. Cool. That looks good enough. Let's see, I would like to change the explosiveness to 0.35 and the randomness 0.4. So it feels like it's a little bit explosive. Let's see. Base size doesn't matter. Then the drawing doesn't matter. Trace. No, the process material and draw passes will be extremely important in that case. So let's start by the process material. Let's create new particle process material. Let's click on it and let's see. Lifetime randomness 0.5. Emission shape should be a box. The direction all over, so 1, 1, 1. The initial velocity, you can change it from 1 to 3. Angular velocity is fine. Linear acceleration 1 and 1. The angle from 0 to 360. And then the color should be black, just as our cube. Okay. And what we need to assign are draw passes. So let's add new, I believe this is box mesh. Let's click on it. And then there's the material, new standard 3D material, and change the albedo to all black. Okay, I believe that was a lot to take in, but now if we press emitting, okay, we can see it emitting, but definitely the draw path is too big. So let's check the size, and I'm going to change the size 0.1, 0.1, 0.1. Let's press emitting again. Okay, now it's kind of cool. If we take a look from the side, it seems like we're hitting the ground right now. Perfect. This is very simple particle system, and as I mentioned, you can do a lot with particle systems in Godot, but as you can tell by the amount of properties, they're really complex, give you a very fine granular control, but I would like to keep it simple. Therefore, this is enough for us. So how to actually use it in the code? We need to go to our script, and then here I would like to get the reference to this particle system. And there are few ways to do it. Actually, we could define the particle system, and in ready, you could say particle system is equal to get node, and then find that node by specifying its name and its path, basically, in our tree. This is a good solution, but what I prefer to do is to use onReady keyword. So what I can do is I can click on that node in the scene tree, then press Ctrl and hold it, and then drag it here into the code window and then release it. And it is using the onReady keyword to define the reference to a node in my tree. Perfect. So now what I would need to do is to know when our obstacle hits the floor, and this is pretty much the same as what we're doing inside of our player. So we will need a signal. So click on the obstacle and switch to the node tab, then switch to signal context, and again we can connect to body entered. Make sure everything is all right, and by default it should be. And then we need to know whether we hit the floor. So we can cast it and check whether it is a floor. And then what I can do is just print floor obstacle. And let's see whether we get that print by running our game. So I'm moving towards our obstacles and nothing happens. And this is because, again, we have to go to our rigid body, switch to inspector, and then press contact monitor on and set max contacts reported to 1. And right now, if we move forward, we get the information about that. So we can use that information to set the emitting property on GPU particles to true. Basically, every single property that you see right here can be accessed via code if you have the reference to a node. The one problem that we might have while writing the code is that we are not always getting the right autocomplete features in our code. So I know this GPU particles 3D is a GPU particles 3D node. But if I will use it and search for the, oh no, okay, it is working. So I can just say emitting and set it to true. And let's see what happens as the obstacle hits the floor. Okay, you can see it emitting everything, but I can tell that our obstacles are directed the other way in our main. So if I take a look at our obstacle, this is the player and this is the front of the obstacles, and we place the particle system in the front of the obstacle, but our obstacles are basically facing backwards towards player. We can easily fix it by just dragging that particle system behind. Okay, let's try this now. And okay, we can see some particles right now. Perfect. The other thing I would like to do is to play a sound whenever the obstacle hits the ground. So what I will do is bring the assets that I'm using into the project, and this will be a sound and font that we will be using. So let's get this going. I'm just gonna drag from my window and put it right here. And is it working? Did it work? Yeah, okay, but it was placed in the wrong folder, so let's move it out. Here in assets, I have sounds, the thumb sound, and also some music that we can play. Perfect. So now I would like to play that sound, that dropping sound, whenever we hit the floor. So to do that, what I will do is I will add another node that will be responsible for playing the sound, and this is Audio Stream Player 3D. Here in the properties in the inspector, I can assign the sound by dragging and letting go. And now the only thing that I have to do is play it whenever we hit the floor. So going back to script right here, I can again create a reference to that node in my script by clicking and dragging and holding control and letting go. Now I have reference to Audio Stream Player 3D, which is responsible for playing the sound. Now I can say Audio Stream Player 3D, play. Let's see how that works. Nice. I can see that we have one problem here that I would like to take care of. In one place, in the obstacles, what I did was, where is it? Oh, here. Stacking, is it here? Somewhere we have like two obstacles stacked on top of each other and they're falling through. To fix that, I can select all of the obstacles, go to collision and make sure that the obstacle is interacting with an obstacle so that we can stack the obstacles on top of each other. Let's see this again. Okay, now you can see that those two are stacked on top of each other. Perfect. So we have our obstacles done. In the next section, we will add the finish line. I would like to add a possibility for our player to actually finish the level by reaching some point. And to do that, we'll create a scene called finish line. So let's go to scene, new scene, choose 3D scene as our base scene, and we'll have to get some visual representation here. So let's create a mesh instance 3D, and we will use a cylinder mesh. Let's go to transform and let's scale it. I need for it to be I don't mean thicker but thinner, so basically that's gonna be 0.5, not here, 0.5 here and 0.5 here. Let's link it and let's set this to 0.2. Is this good enough? Let me see. I think that's good enough. And I will name this left column. And let's move it to the side, duplicate it, and move it back here. Okay, so this is going to be our finish line. Let's name this right column, and we shouldn't really use spaces here. Doesn't look good. And let's name this finish line and save. And let us think. Let's set the proper position for both, and I believe that 4 and -4 should be good. And let's see, let's place it in our main to see how this looks. So main, instantiate child scene, finish line. Let's move it to the finish. Let's focus on this. And I can see that this is way too small to be visible. So go back to finish and let's change the scale. And this is the wire scale. Let's unlink this and set this to 1 or maybe even 1.5. Way better. Okay. And now what I would like to do is to make it more visible, and we can do that by changing the material that we are using here. So surface material override, let's create new standard material 3D. Let's change the albedo, and I will change this to green. And then what we can do is make it more visible, but adding the emission, and the emission should be, I believe, white. No, the emission can also be like green. And then we need energy multiplier to be higher, and you can see it will emit a light. Okay, and then what we can do here is also surface material override, use standard material 3D, click on it, change the albedo, and let's make it, I know, pink, light pink. Go to emission section, enable it, also bump it up, and change the light basically to the same color. So I can just go to the albedo, press Ctrl, just copy it, Ctrl C, emission, go into the hex and apply that. Press enter. Okay. Now, if we go to main, that should be rather visible. So after crossing that line, we should be informed that user is done with given level. And how we can achieve that is we need to inform our game that something happened. We need to inform our game that user crossed the finish line. And as mentioned before, we can use signals for that, but there is no built-in signal anywhere here for player reaching given place. So we can do it on our own and define our own signal. Let's start by adding area 3D, and let's place it a little bit lower. We'll adjust that in a second. And for our area 3D to detect stuff, it needs a child that is very well known by us already, collision shape 3D. And let's add a shape here, and that's gonna be a box shape. Okay, let's align it and let's place it at the bottom. Basically, it can be squeezed to a plane, really, and then extend it and place it at the bottom. We can disable the snap just to align it properly with the bottom. Okay, that should work. And then we need a script for our finish line. So let's click attach a new or existing script, place it in the scripts folder, and here let's get rid of everything. In this place, we need a signal from our area about the information that somebody entered that area. So I can click on it, go to node, and here I can find body entered. Let's connect to it. Let's connect to our script. And here I know that the only body that can enter the finish line is going to be a player. Here I would like to inform our game that the level was 1. So how to do it? We can define our own signal called level 1, and then we need to emit it. And now any other node that is connected to that signal will be informed about that event in our game happening. Okay, we can go back to main. Let's see, this looks correct, or is it? Let us check. This is the finish line. Now it looks correct. Okay, so how can we be informed about that player crossing the finish line? Well, what we can do is in our main scene, we can create a node that will manage the game state. So I can add a child node, and that's going to be empty node that won't have a visual representation or a place in 3D world, but will only have a script attached to perform some work for us. So let's add this. Let's name this game manager. And let's attach a script to it. So let's change the location to scripts. And let's change the name to match the casing here. And create. Okay. So here I can get the reference to finish line by dragging and holding control and dropping. And then on ready, I can say finish line, and I would like to connect to the signal, and the signal is called level 1. But as I type it, you can see that I'm not getting the autocomplete. And to fix that problem, I can cast my reference to, oh, I would like to cast it to finish line, but I cannot. This is because we did not define the class name here. So if you go to the finish line GD and finish line scene, I can say class name, finish line, and now in my game manager, this should all work because I defined that class. And now if I press Ctrl space here, I get my autocomplete. So I can connect to that signal. So we can connect to it by calling connect on that signal. And then we need to provide something called callable, which is basically a function, or rather reference to a function. So what should happen when given signal is emitted in that script? We can create our own custom function by using the func keyword and specifying the name. And if we need, here we can provide optional arguments, but we don't need it here. And for now, we will only print level 1 here. And now we have to provide that function here somehow. And the mistake that you can do is basically calling a function here, but we don't want to call it, we need a reference to it. So basically we get rid of the parentheses that will call the function and just provide like the name of the function. So these are the same. Let's see whether that works and try to get to the finish line. So let's see. We're going to finish line and we have level 1. Perfect. We can now do some stuff with, for example, our player. So let's get the reference to our player. And we can do this by going to main. And here I can also drag and drop the player, or alternatively, I could get reference to a player by saying again, player, get tree, get first node in group, player, because as you remember, we added the player to a player group. And then when the level is done, what we can do is stop the player. So we can do player. Let's see, we have to disable the linear velocity. Oh, and we don't know that this is a player, so can we cast it maybe? Could not find type player in current scope, always read your errors. This is because if you go to player and go to a player script right here, we didn't add the class name. So let's try adding the class name here and go back to game manager. And now this is fine. So now I will get the proper autocomplete. So linear velocity, you can set this to vector 3, 0, and then we can also call freeze and set it to true, and that should stop our player. And to make testing easier, let's go to 3D and bring our player way closer to the finish line. Okay, so let's see, this isn't working for some reason. and this is probably because I made a mistake and did it on already, which will disable the movement of our player, and I want it here. Okay, and yeah, now we're done. Perfect. So this is our finish line working. In the next section, we'll add a simple UI that will count how much time it takes for us to get to the finish line from the start. So in this section, I would like to start working on the UI of our game. And the UI might be a bit too much because we'll simply display a label with the time running. So to do that, we can go to our main and we'll add new scene, or basically we can go to scene, new scene, that's going to be even better, and choose other node. And to start working with UI, we'll add the canvas layer, which is like a root node for the UI. I'll call this UI from the very beginning and save the scene. And in that case, we'd like to change our context to 2D, because even though our game is 3D, the UI is always 2D and flat. Okay. We'll need to create a very simple UI for that. And I would like to create a child node. And if we get rid of that, basically here you have a list of the nodes that you can inherit. And if you go to and search for control, basically every single control node, or the node that is inheriting from the control, is some kind of UI element that controls how the other UI elements are placed on the screen. And we're looking for the center container. And you can see it's being placed in the top left corner, and we can manipulate it and change it. But what I would like to get is that center container to cover all of the viewport. And to do that, I can go here for the presets of the for the anchor and offset values and find here full rect. Now it covers the full viewport. As a child of that, I would like to add another UI element called label, and it is being placed in the middle of the screen, but I would like for it to be in the middle, in the top of the screen. So I can go to sizing settings, or sorry, oh, I will have to go to the center container and find the placement for children and set it to top. Sorry, I don't want to have the center container cover the full screen, but rather cover only the top. So now I also have the label based at the top. Here in Inspector, I can add some text for the label, and I would like to change the font, the color, and the sizing of the label. Here in Inspector, I will find all of these properties. And I will have to go to Theme Override section, and here change the font color to be black, and then even the font can be changed. In the assets, I have TFF file with Canit medium italic font. I can simply drag and drop it here, and the font is changed. Then for the font sizes, I will set it to, I believe, 48. And now if I run my game, I won't see anything because I did not add the UI to main scene. So let's go and do it. Instantiate child scene, UI, and now I can find it right at the top where I place it in my canvas layer. Okay, let's go to the main. Let's place our player back at the start. Perfect. And then let's make our UI work. And of course, to make it work dynamically, I will need a little bit of a code. So let's attach new script. Let's go to scripts, open, create. What I will need here is the reference to the label. So what I can do is I can drag and drop it and hold Control and place it down here. And I'm getting the reference here, as you can see, not only by a name, but I have to traverse the full path from the root to a given node, right? I have to go into the center container and then into a label. And this is fine when the path is not so long, but you can imagine that those nodes can be nested inside of the other nodes. And this name can be rather lengthy. So to shorten it, I can right click on the label and press access as unique name. And now if I try to recreate that reference by dragging, pressing Ctrl and dropping, you have that percent sign, and this is now shortened and using unique name. Cool. So now to display the time passed from the start of the level, I can do something like define the variable for the time passed, and at the very start it is 0. And then in process delta, I can say time passed plus equals delta, and I can display this, right? And plus equals operator is basically the same as times pass plus delta, but it's just shortened and more elegant way. And don't worry that you don't know all of the quirks and don't know the GDScript inside out. It will come with time and practice. What you can do is search for GDScript reference, and here you get the overview of the language in the Godot documentation. Okay, on the label node, I can see that I have the text property. So I can access that and say label text and display the time passed. So let's see how this works. Oh, I cannot. This is a string and this is going to be a number, right? So this is some text. It expects some text, but this is a number and we have to convert it. So I can use str to convert the number to text. Okay, this doesn't really look good, right? What I would like to have is the text to be displayed with 2 decimal places. And I can do that by using string interpolation in GDScript. So I can say %.2f and then %time passed. So this basically means create a text that has 2 decimal places as a float from the variable time passed. This looks way better, right? Perfect. And we have our basic UI, but what we would like to do is to stop the time running whenever we finish level. So I can create another function and call this on level finished. And I can say we can create another variable here is time stopped and set it to false. And if time is not stopped, so this exclamation is a negation, means basically is time stopped is equal to false. These two are pretty much the same, but this is like shorter. If time is not stopped, and it's not stopped at the start, and then set is time stopped to true when we finish the level. So now we have to call that method whenever the level is finished. So let's go back to our game manager and our main scene, and let's get the reference to UI here. Let's see. Here in the game manager, we have on level 1. So here I can call UI on level finished, and let's see whether casting is gonna help us here. So I'm going to add a class name, UI, and then in game manager, I'm going to cast this to UI, and then if I press Ctrl and space, I get my autocomplete. So let's try and finish our level. Let me through. And the time stops. Perfect. So this is the basics of our UI. One other thing I would like to add is the panel that we display whenever the level is finished. So to extend our UI, I will go with add child, center container, and I will call this one next level container. And in that case, I'm gonna actually make it span across the whole screen by going to anchor and offset preset and choosing full rect. Then inside of it, I will add a panel, and it's not really visible here, but in the layout, I will set the custom minimum size to be 300 by 300. And then, as a child of that, I will add a button. And I will add some text here. The text of the button is going to be play next level. And let's center it. Okay, so there are a few things that we need to add here. One thing being we need to be informed in our code whenever the button is pressed. And as you can imagine, we'll use the signal for that. So switching here to signals, I can see that on a button I have press signal. And if I connect to it, I'll print button pressed. Let's run the game. And if I press the button, it is being pressed. But of course, this part of the UI should be displayed only when we finish the level. So what we could do is hide it on the very start, get a reference to it, and then make it visible when the level is finished. So right here, I can change the visible property. Next level container dot visible set to true. Okay, and let's see right now. I'm trying to finish this. No, don't fall down. And now it's visible. Perfect. So to add a second level and the management of the levels, We will do that with the JSON file in the next section. Let's continue working on our game by creating the main menu. So we'll leave our main scene for now and create new scene. That's gonna be a canvas layer with root, and then this is going to be UI only scene. So let's change the name to main menu. Let's save it, and let's start working on the stuff we would like to see here. First, as a child, I'm going to add a panel and go to 2D, and I will make that panel span across the full viewport rect. But I would like for it to look a little bit different. So I'm going to go to Inspector, Theme Overrides, Styles, and create new style box flat. Click on it to expand, and I'm going to click the background color and change it to full white. And I would also like to add the border width of 8, and then also border, it's going to be black, and change the corner radius to also 8. Nice. And we will be creating another scene where we will be choosing the levels, and I would like to have the very same panel there using the very same style. So what I can do is I can save that style by clicking on that arrow here and choosing save. And I will name this panel menu, and I will create new folder here, call this styles. And then we can save that configuration of the site as a file and reuse it later. So let's save. I'm gonna add another child here, center container, and I will place it in the middle, and I will start adding children to it. I would like to have a label and 2 buttons that are arranged in a column. To do that, I can add another child and search for box container, and you can tell by the icon that it has those rows. Okay, and then in here I will start adding stuff that I need. So label and 2 buttons, and I can just duplicate them. And as you can see here in the screen, as I click through them, they are arranged in a column. Perfect. So let's start by adding a name for our game, and I call this Cube Race. And it can't be seen because it's a white font color on a white background. So go to Label, Control, Theme Overrides, Colors, and change the font to black. Then change the font itself by grabbing the font from Assets and dropping it in. And I will also change the font size to be something like 120, maybe a little too big, but this is fine. And going back to our buttons, I'll add a label here called this Play Game. And here I'm gonna go and call this Quit. So I can change the naming here, Play Game, and here Quit. What I can also do is change the font right here. So go to Theme Overrides, Fonts, and also drag and drop the font that we are using across the game. Perfect. For now, that's not doing anything. And if we run the play command, it's gonna run the main scene because we chose that scene to be main scene. But to run the current scene, I can go here. You can see this is F6 key on the keyboard. But if I press that here, now I'm running the current scene that I am in. With everything set up correctly, now it's time to make it dynamic. So let's click on our main menu. Let's click on Attach Script, change the location to Scripts, open and create. And now the only thing that we need is to connect to pressed signals on our buttons. Let's start with quit, change the context to node, find pressed signal and choose connect. And here I would like to just close our game. So I can do get tree, quit. Let's try this by running current scene, press on quit, and the window closes. Now, I would also like to connect to on play game pressed and move us to a different scene, which is like level select scene. So let's create new scene. It's gonna be also UI only. So let's choose canvas layer, change this to level select, save it inside of scenes folder. And then basically what we can do is copy, or let's add a panel here. And as you remember, we saved the assets, the panel style here. So I can go to theme overrides, styles, and instead of creating new style box, I can choose quick load or load and load it. And then the only thing I have to do is to make it span across everything. So here, let's add a label. Let's place it, let me see, let's place it at the top. And maybe one thing I would like to change here is how far from the top that label is. And to do that, I can, for example, add margin container, allows us to add a margin. And in that margin container, I'm gonna go and find theme overrides constants and override left, right, and top with value of 16. And also make it span across. And then we can add the text to a label. And let's place it at the top with vertical alignment. And we can say select level. And we need to change few properties here, mainly the font. So go to assets and drop it. The color, the alignment, can change the horizontal alignment to center and vertical alignment to center. And then font size, let's make it big. And then we need a buttons to place and to run our levels. So let's add a child node here, find the center container. Then let's add another child node, and this is going to be HBox container to place other child nodes in a row. Here I'm gonna add buttons. So let's add a child node, button, and then button 2. And this is going to be, this is going to be 1 for the first level, and 2 for the second level. And they are rather small, so we can go to theme overrides, font size, and change it to something like 32 or maybe even 64. And right now one thing I would like to do, let me just change the font size here, is to make them square. So I can go to layout, custom minimum size, and set it to 100, and here go and do the same, change to 100. Perfect. Now, how's the game going to work is that we will have just first level available on the start, and then when users finishes it, the second one will become available. But to do that, we will need a bit of code. So let's go to level select and add a script. Change its location to scripts and create. Okay, so the one thing that we will need is something called level manager and persistent data. And there are different ways to store the data in your game. You can do it on a server, you can use player configuration, but basically when creating a save file, one thing you could do is use JSON format, which is pretty cool because JSON format, as you can see, is an object that is a dictionary that has a key and a value, and we'll be using just that format. So let's start by creating new folder here and call this persisted data. And inside of here, we'll create new text file, and I will call this levels.json. So let's open it up. And here we will store very simple dictionary with a key called max level and the value set to 1. So this is the unlocked level. And make sure that you have the proper format, meaning this is in the curly parentheses, this is a string, and then this is the number value. And to manage this file and read our level, we will need a script. The problem is that we'll use this script across multiple scenes. So what would be the best way to do this? To have like a global script called singleton, what we can use is auto load feature in Godot, and the scripts created there are the scripts that are staying the same across all scenes, and you can access those globally. And we can define one by going to project settings, auto load, and we can create new script. Now we'll call this level manager, and I will click here and place it in scripts, and the script file is going to be level. Oh, I can't do it like this. We have to, because it doesn't exist, so we have to do it like this. Level manager. Let's add it, and now we can find a place for it in scripts. So this is going to be like global variable. You can check this in and out right here. So let's open it up. We're going to scripts, level manager, and here we'll write the code that handles the JSON file. So we'll have two functions here, get max level, which will return the value that we have stored in the JSON file under max level key. So first what we need to do is read the file. You can do this by accessing file access class, calling get file as string, and you can provide the path to that file, right? And we have it here, the path. So I can just copy it, go to level manager and place it, So what I did to get that path is I clicked on the level JSON 2 times, and then in resource you have a path property. And then I can turn that string, because we're reading that file as it is as a text. I would like to turn that text into a dictionary. So I can say JSON data is equal to JSON class parse string level file. And then just to make sure everything is all right, we can check whether JSON data is dictionary, and then we can return the key inside of it called JSON data, and we know that the key is max level. Make sure to use the square braces here when accessing the key of a dictionary. And then another function we need is the way for us to unlock the next level. So unlock level int. We read the file. So basically we can copy those two. Okay. And we have our JSON data right now. Check whether this is dictionary. If it is, we can override the value under the key. And then say, we need to turn that dictionary back into text. So JSON data string is called to JSON stringify JSON data. And you can see that these two methods work together. We read the file as a string, we turn the string into dictionary. We modify the dictionary, and then we turn the dictionary back into a text that we can save. And to save that, I can say file access, open, pass the very same path here, and give us access to write. Oh, sorry, that should be a comma. And then we can say store line and say JSON data string. So we write it back to the file. Perfect. With that code wrote, we can go back to our level select and start writing. So what we need first is to make sure that our buttons are disabled and cannot be clicked. Right? And you can see that they're grayed out and disabled, so at the very start no level can be accessed. And then on ready callback, what we do is we read the max level, and as you can see we have access to it globally. We don't need no reference, it's in the global scope. Then we get the reference to the buttons, so we can do it by storing the button container here. Let's name this button container. And you can see again we have that very lengthy path. You can change and fix this by clicking right, setting access as unique name. This will give us that percentage here, and then if we click, hold Control and drag, we have that shortened access path. So buttons, we need to get the access to the both button 1 and button 2. Therefore, I am accessing the parent node, and I can get all of its children by calling button container get children. And then I need to do something for each of the child. Now I can write a loop, the for loop, to access button 1 and then button 2. For I in buttons, if I is less than buttons size, oh sorry, I don't want to iterate buttons, I want to iterate max level for I in max level. So if we have 2 levels unlocked, we'll call this code below the loop twice. Or if we have 3 levels or 4, that's how many times we'll call that code that we'll write right now. And I is going to change from 0 to 1 to 2 to 3 in each iteration. I is less than buttons size. Buttons at I disabled is false. And this, what we have here, is array access, because we know that we have multiple buttons here. So here they will be available as an array of button and button 2, right? So they're stored together in a structure called array, which is starting from 0 index, and then we have 1 index. And that's how we can access button 1 and button 2. So at the very start, we re-enable them based on the current max level. Okay. So with that out of the way, what we can do is we can connect to our button presses. So let's go to node, connect, that's going to be button press, and here also button 2 press. So whenever we press a button that's enabled, we would like to change a file. So get 3, and we can call a method here, change scene to file, and I'm going to define main tscn. Oops. Let's see. Main tscn, and here for now we'll just print change to scene 2. Let's try and run the current scene, and we can see that this is unlocked because our max level in JSON file is set to 1. But if I will change it to 2, now both are unlocked. So what we need to do is basically at the end of our level, increase the max level here in level JSON, and to do that we have the level manager method unlock level. So going back to our main, which is like our first level, and our game manager, here on level 1 I can say level manager unlock level 2. This is very good. And then what I need to do in our UI on button pressed, I need to get 3, change scene to file, and that's gonna be level select tscn. So to test that, let's grab our player, move it to the end, and let's see how that works. So I'm moving to the end, I press play next level, and now level 2 is unlocked. Okay, and it's gonna inform us that the file was modified. And here we have max level 2. So let's test the happy path. So let's start with the main menu here. We have to connect to the play game button, press. Let's do this. Let's go get 3. change scene to file, level select TSCN. So this is the main menu. Let's play game. Let's select level 1, play next level, select level 2, and now change to scene 2. The one thing that we need right now is to build the second level. So let's get new scene, other node, use empty node, call this level 2, save it, go to 3D, and we need a few things here. So let's instantiate those. We need the floor, we need our player. So let's instantiate player here. The player has to have the camera. So let's add camera 3D. Let's pass it here as a reference. Camera 3D. And I'm not gonna bother with obstacles here, but you can add those as you wish. So I'm gonna just add the finish line. Let's place it right in front of our player. What else do we need? Oh, we probably need, we're going to need the UI. So let's go to here and add the UI. And to make it work, we need the game manager here. So let's go back to main. Let's choose our game manager, and to reuse it, make it as a reusable scene, I can right click and choose save branch as scene. Let's save it in our scenes. And now I can instantiate here. Game manager, let's move it out here. Does it need any references? I don't think so. Are we missing something here? Let's try and play it. And that doesn't look good. And this is because we don't have a light. So basically I'm gonna copy this light. Let's Control C and Control V it. Let's run it now. Still not good. Let's see the camera. Okay, the camera also has to be set up and turned properly. Let's check how did we set it up in level 1. So this is -25. Is this camera? Yes, this is camera. -25, -80. So -25, -180. Sorry. Okay, try this again. Yes, and now if we go through here, okay, this is too high. Okay, is this correct now? I believe it is. Let's try this again. Oh no, that's not it. Play current scene. Okay. Invalid. Oh yes, this is the problem. In the level 2, we did not add the player to the group. Let's fix that by going to player, choose node, group, manage group. Let's add that group here and find the player. Add. Okay, now that node is a part of the group. Try this again. And we can play the next level, but that was the second level. So the only thing I would like to add as a bonus in the end is music. And this is going to be very, very simple to add. We can go to main, which should be really named level 1. and we can add a child node, and that's going to be the audio stream player, not the 2D or 3D, because they play in a special place, meaning they're for the sounds in your game. But if you'd like to play music just out the normal audio stream player, not the 2D or 3D, let's add this. Go into inspector. In assets, you'll find music MP3. I will lower it to -40 dB. You can also copy that node and paste it in level 2. Oh, sorry. Copy and paste in level 2. And let's see whether we have music. And it's not going to play, of course, but if you turn the autoplay property here and in the main, let's try this again. Yeah, you can see it, you can hear it playing. Maybe just to -20 and -20. And if you play it, yeah, you can hear it. So basically, we can now test the complete path changes to 1. And let's start with you can go here to choose the scene to start playing, and I'm going to choose the main menu. We play the game, the second level is blocked. Select the first level. We play the next level, we can select level 2, and we didn't hook it up, of course. This is fine. Go to level select, and here on button 2 press, I can say get 3, change into file, level 2 tscn. Let's see. Let's run this again. Play game level 1. Play next level, level 2. And play next level brings us back to select level. And this pretty much sums up making a very simple game in 3D in Godot. I hope I wasn't doing it too fast. I tried to make it as beginner friendly as possible, even given the fact that we discussed some advanced topics like change the scenes, writing to persist data, UI, sounds, particle effects, the input control. One advice from me is, if you finish that tutorial, to memorize it better and to learn more, try to enhance it by adding different types of obstacles, maybe ones that are moving up and down, adding more levels, maybe more particle effects, and writing more code. Following the tutorial itself, is not going to make you a better programmer or developer, but what you can get is you being stuck in the tutorial hell, meaning you will only copy what you see in the screen, and this is not the best way to learn. Actually, the best way to learn is to follow the tutorial, but then always add to the game your own ideas, your own perspective, your own solution to figure out the stuff on your own. And this is the best way to learn. Today I just reached 3K subscribers, which is like a big thing to me. So thank you very much for helping me and for making this channel grow. I have next tutorials in the works, and I will keep on making them. Yeah. Let me know in the comments if you enjoyed it, what type of game you'd like to make, or what type of tutorial you would like to see on the channel. Thank you and goodbye.